Hi friends, welcome to my channel. This is a new video. It is about recurring series and a few basic properties. So we are going to just solve two problems and let's see like what we can find out from these problems. Okay, these problems are from a book called Taste of Mathematics at 10+2 level, and it is published by Indian Statistical Institute itself. So let's have a look at the problems. So first of all, let's look at this problem. Let's call this one A and this one B, right? Let me change the pen. I'll take the red one and then the thickness. Yeah, I think this is fine now. Yeah, this is much better. Okay, so this is our problem number. Let me erase this and draw them again. Okay, this is my A and this is B. Okay, so in A we have got this recurring relationship, right? Xi plus 1 plus xi plus xi plus 1 is equal to some constant. Okay, and we have here we are given the value of x10 and we need to find out the value of x1. Let's see how to do it. Okay, first of all, as you can see, we can write xk plus 1 as just this constant minus xk, right? This k is just this I. Okay, we have already used k for the constant, so let me make the constant c. Okay, so what can we do now, right? Let's see if we substitute xk, what do we get? Okay, let's see, c minus xk would be now c minus xk minus 1, right? By the same logic, because in place of k plus 1, if you put k, then this would be just k minus 1, right? This would be just x k minus 1. So basically we can see that after every two terms it repeats, right? So basically we are given the value of x10. Okay, so x10 is suppose 1. Now x9 will be given by this formula, right? C minus xk, which is 1. We know that c is just k, right, in this guys, so this would be just k minus 1, and x10 8 would be same as x10, so this would be just 1. Similarly, x7 would be k minus 1, right? And you can see that for even number it is 1, for odd number it is k minus 1. So here k1 is odd, right? So the answer would be k minus 1. Okay, now let's look at problem number B. So what problem number B is saying, that we have given this recurrence relationship explicitly and we need to find out about two terms, this 465 and 466, if they are odd or even. Okay, so let us notice something. Okay, so how to approach this one, right? We are given a0 and a1. So if we are given two terms, based on that we need to predict how the next term is going to behave, right? Like that only we are going to build up the whole sequence. So let me just make a table so that it's easier to understand. Okay, so this is our a n minus 2, this is a n minus 1, and this is a n. Okay, so there can be four cases, right? Both of them are odd. It can be odd and even, then even and odd, and even, right? So if both n minus a n minus 1 and n minus 2, if both of them are odd, then multiplication is also odd. Then if you add another odd number, 1 is an odd number, right? Then we'll get the even number. Okay, similarly for the rest of them, you can see that we are multiplying by at least one even number, so this multiplication will be even, and if we add an odd term with this even multiplication, then we'll get odd, right, for all of them. This is odd, this is odd, and this is odd. Okay, so Now let's try to calculate a few terms, shall we? So first of all, a0, that is odd, a1 odd. Now we know that if we have two odd consecutively, then we get a even terms, right? Even term, I mean, this is even. Now we get one even and one odd. So next term would be obviously odd, right? Because only two odd gives us even. Now there are not two odds, right? a1 and a2, both of them are not odds. So here we'll again get odd. Again there are no two odds consecutively, so we again get odd. But after writing two odd, you can see that a case for even is building up, so this would obviously be even because we see it from here, right? Similarly, you can see a trend, right? It will just go on like odd or even, and so on. So basically, if you take this subscript and add 1, if that is divisible by 3, then it is even, otherwise it is odd. Okay, so let's see. We need to add 1 with this and 1 with this, right? So we need to check for 465. So for that we need to see whether 466 is divisible by 3, right? Now how to check whether 466 is divisible by 3? You can just add them up, right? Add the digits. If the sum of the digit is divisible by 3, then whole number is divisible by 3. So this sum is 16. 16 is clearly not divisible by 3. So this is not divisible. Similarly, for a 466, we see that 467, the sum would be 17, right? If this is 16, this would be 17. Even this is not divisible by 3. So this is not even, this is not even. Both of them should be odd. So a465 is odd and a466 is odd. This is the correct option. So I hope you learned something about series today. So the first thing is that whenever you get something like this, you should not directly get into computing things, right? Because probably the question setter, he does not want you to calculate the whole thing, you know, just putting in all the values, because that makes no sense. If you get like 1000 terms, or suppose in the second question we have to calculate the 465th and 466th term, right? And if you manually calculate it, and it is going to take a lot of time, right? So there's always these small things, right? If they're in the question they're asking about odd and even, then probably you should think about, okay, if a n minus 1 is even, a n minus 1 is odd, then what might be the possible cases, and blah blah blah. You know, you can like slowly build your logic up from the question only. And the option, obviously they are also giving you a lot of hint right away, right? I hope you learned something new from this video. If you like the video, please press the like button. Don't forget to subscribe, and try to, you know, press the bell button as well, so that you get the notification whenever I upload a new video. Okay, hope you are taking care of yourself and studying hard. Keep on solving problem, keep on having fun with mathematics. I'll see you in the next video. Till then, take care.